Okay. First of all, a couple of useful equations. How do I work out the number of moles of something with mass? Moles equals grams divided by vector mass. In this question, which is slightly more difficult, I've got information about concentration and volume. How can I work out moles? All I need to do is the concentration multiplied by the volume. But because the concentration is in moles per litre, what was my volume be? Litres as well. My question, remember to millilitres, all I need to do is change that. Right, so if we're doing a stoichiometry problem, number one, what is the first thing I need to do? Given a nice equation, I need to balance the equation. How am I going to balance that equation? I like to focus on things that aren't hydrogen or oxygen normally. So, for example, sulfur on the left, we've got one. Two here. Right, I got there. Two sodiums on the right, so I need two on the left. Yeah, I've now got 4 hydrogens on the left. So I'm going to have to put 2 there. Let's see if that works for my oxygens. Got 6 on the left. I've now got 6 on the right. That's all good. Got 1 sulfur on the left, 1 on the right. That's my balance equation.
What about under 4?
I've got 4 on the left. I've got 2 in sulfuric acid. I've got 2 in sodium hydroxide. That makes sense, right? Yeah. Right, balance my equation. What's the next thing I need about my reactants? I've got some information about volume and concentration. I've got some grams. What do I want to convert both those things into?
Moles.
I always want to find out the number of moles of my reactants, because that means I can then find out the limiting reactant and I can carry on doing anything I need. Okay? So, first of all, for sulfuric acid. Okay, in this case, slightly more difficult because it's given some information about the concentration and volume. So to work out the number of moles, and perhaps I will just do a dotted line. Let's just keep things separated so we can keep an eye on what is what. Right, sulfuric acid. Let's work out the moles down here somewhere. Moles of sulfuric acid. I need to do the concentration, which is 0.4, multiplied by volume. What's the volume in litres? Exactly, I've got 400 millilitres, which actually is 0.4 litres. So the number of moles of my sulfuric acid.
Is that always step 2?
Sorry?
Is it always step 2 to convert everything to moles?
I would, step 1, balance an equation. Step 2, work out the number of moles of all of your reactants. So the things that are reacting together. 0.4 multiplied by 0.4. 0.16, yeah, 0.16. So what I'm going to do actually, I'm going to write that right underneath sulfuric acid, nice and clear. Right, what about my sodium hydroxide? I've been given some information. I've got 8 grams of sodium hydroxide. So now I need to use mass and the molecular mass. So I need to do the mass in grams, which is 8, divided by the molecular mass of sodium hydroxide. What is 32 plus 1? Sorry, 23 plus 1 plus 16.
30.
Is 40. Okay? And that is going to give me 0.2. So again, I'm going to write the number of moles right underneath that reactant, so it's nice and clear. Okay? Right, let's keep this nice. Okay, I've got a number of moles of both of them. How do I work out, what's my trick to work out which is the limiting reactant? It's going to involve the number of moles of each reactant and the coefficient. Divide the moles by the coefficient. So, my little trick, and I'm even just going to call this trick, to work out the limiting reactants, I need to take the number of moles, in this case 0.16, divided by what's the coefficient in front of the sulfuric acid? 1. So actually, that just gives me 0.16.
What's the thing on moles equals?
That's the moles equals concentration multiplied by volume. If I'm given something about the concentration and volume of one of my reactants, not the mass, I can work out the number of moles just by multiplying those together. Right, so I'm going to do the same thing for my sodium hydroxide. I've got 0.2, this time divided by a coefficient of 2, which is going to give me 0.1. So, which of those is my limiting reactant? Why this one? Because it's a smaller number. This is a smaller number, so that is going to be my limiting reactant. What I've told my class to do when they know the limiting reactant is put a nice big square around it, because actually that is now the only reactant we are interested in. The other one is what we call the excess reactant, so I'm going to forget about it because that is now not relevant for me. So, my question is actually asking me what mass of sodium sulfate should be produced. So let's just make sure we know that is the relevant one there. I need to work out my moles of sodium sulfate. So I can use my rule of 3. I need to do 0.2 multiplied by the coefficient here, which is 1, divided by the coefficient there, which is 2, which is going to give me my answer of. For the rule of 3, I need to do, let's go back. I will rewrite that underneath to make it clear for the rule of 3. All I'm worried about is the numbers. So on top, I've got a big coefficient of 2 sodium hydroxide, producing a coefficient of 1 for my sodium sulfate. Underneath it, I've got 0.2 moles to give me X, which is what I'm trying to find out. So the rule of 3 works. I take my number at the bottom here, I multiply by the number up on the other side, I then divide by the number on the same side, and that gives me X, which is going to be what? 0.2 multiplied by 1 divided by 2 equals 0.2 multiplied by 1 is 0.2. If I divide 0.2 by 2, it is 0.1, got there eventually. That is going to give me 0.1 moles of sodium sulfate. Is that my question finished? No, it asks me what mass of sodium sulfate should be produced. So,
if you did all that, you forgot to do that.
what, converting it to mass?
No, if you messed up the numbers, you got the whole thing right.
I would recommend you don't mess up the numbers, especially if they are quite nice, easy numbers like they are here.
We're gonna have to.
It's one of the examples.
No, this is not one of the examples.
One of the examples.
Right, finally then, I've got the number of moles. I need to change that into a mass using, again, this equation over here, but I need to rearrange it. How do I work out the mass? I need to do what? What do I need to do to work out the mass? I need to rearrange this so I get just G in grams.
You replace mole by 0.1.
I need to multiply moles if I rearrange this, multiply it by the molecular mass. How many moles do I have? I've got 0.1 moles. What's the molecular mass of sodium sulfate? I'll give you a clue.
20.
It is 142, well done.
Um,
All you need to do is add up 2 sodiums,
Oh, yeah.
1 sulfur, 4 oxygens, it's 142. What is 0.1 multiplied by 142?
What?
0.1 multiplied by 142. It's 14. 2. What units are we talking about if we're calculating the mass? 14.2 grams. That is my answer. How could I make that slightly more difficult for you?
No.
Oh, this is really good.
I'm going to prepare you, just in case. I could say perhaps at the beginning. Right, girls. I wanted to make it slightly difficult, slightly high level, and I said to you, if I did that experiment in the lab and I only got 12.2 grams, what was my percentage yield? How do I calculate it?
The percentage you was.
I need to take.
Wait, it was the experimental yield divided by
The theoretical yield.
Yes.
What's my experimental yield? My experimental yield is 12.2 grams. Theoretical, we calculated before, if everything goes perfectly, is 14.2. And how do I turn it into a percentage? What do I multiply it by?
100.
100.
Yeah, 100.
So 12.2 divided by 14.2 is going to give me 86%, or a yield of 86%. Fantastic. Easy? Of course.
I mean,